Hi there. Today we're going to go through how to set up the autonomous REST connector for your demonstration. Now you should have already watched the first video, which shows you how to configure the ARC for either Windows or Mac iOS. This video is purely related to what to do next after you've got the installation completed. So without further ado, let's get started. First things first, we're only going to show you how to set this up using dbeaver. You can use whatever SQL IDE you choose. However, these instructions are limited to dbeaver. Now, if you've just installed the latest version of dbeaver, you will notice that from the previous video that I had set up, the view is slightly different. It doesn't matter. You still can get the access to the drivers that you want. However, if you want to go back to the original view, you just hit this classic view here, and then you can see the way that I had set it up in the last video. But moving on from there, as you'll already noticed, there is no ARC connector. So what we have to do is build one. Now, I did show you in the last video how to do that, but we'll go through it again. Simply a matter of clicking on Driver Manager, hit New, then give it the name ARC, the class, and as you may recall, I showed you where to find that class, which is on the Autonomous REST Connector website under the drivers and database class, and it's in this location here. So we paste that there, and then in the URL template, in the last video, I just sort of said to trust me. We're going to play a little bit more with the URL template. But first, we're just going to build this driver, and then we'll talk about how you set up the different parameters for that URL template. I'm just going to copy into here a URL that I know works, and then we'll talk about that later. So we go back to our file, we select our Java file, and you should have remembered how to do that, which is basically, in your case, it will be the where the program file is. I've moved mine into a different location to make it easier to find. Once we hit OK, you can see here ARC now appears. So once we've got that, we can connect to our database. So we create a new connection. We select our ARC database or ARC driver, hit Next. There is a bunch of parameters. We'll go through that in a moment. Hit Next. And by dropping down, we will be able to connect to our data. Okay, so here we are connected to our first autonomous REST connection database. So what does it all mean? Well, if we have a look at this connection here, and we'll talk a little bit about how this information is built in a moment using the REST API schema that we're using to connect in this case. But what we wanted to do now is just talk through a little bit about what the ARC is doing. As you can see here, there are a number of schema tabs within the SQL IDE. If we open up the auto REST one, this is going to show you tables, views, indexes, procedures, and data types, etc. These are the normal things you would expect to see when you connect to an SQL database. So in effect, the way that the ARC works is it presents the information from the REST API as if it was a database. It's quite clever. So if I open up the tables tab here, I can see a number of tabs. If I open up the views, there are no views. If I open up indexes, this is showing you all the primary key, and if there was any secondary key relationships, they would be appearing in here. If there was any procedures, they'd be appearing here, and all the data types that are available within the set of tables appear here. And the ARC has built all this based on what it's read out of the REST API. Now, to show you what the REST API looks like for this particular example, what we're using here is the SpaceX API, and using this tool called Postman, I can simply just paste the API string in here as a get command, hit send, and it will run off and grab all of the data from that API extension or that API web page. Now, as you can see, if you were to try and run queries against this, it's impossible without writing either some kind of code from JavaScript that would convert this information into a CSV file that you can then import into something like R or Python. There are a number of other tools around that will convert an API into a CSV file. However, you still need to then convert it into something that can be read as an SQL. The beauty of ARC, which is why it's such a powerful tool, is it enables you to just run queries as you would normal SQL queries against these tables. So just having a quick look at this first demonstration, what we've got here is rather than going too much into detail about what the API is returning, what I want to show you here is that each of these tables have got values associated with them. You can see here there are a number of columns within the tables. If we open up each of these, but what happens is the ARC then will put together a summary table, and what that is it glues together a bunch of information that it finds out of the API. And what we can do is we can run queries against that table. So you can run queries against any of the tables, but in some cases, as we'll see with one of the other examples, there isn't a lot of information. So sometimes you just get nothing back. So it's important to understand how the ARC is building these tables so that you can understand what ones you can actually query against. But for this one here, I happen to know that the V2 launches is the query result, and that's the one that we really want to query against. So just by using standard SQL language, we can run a select query from auto rest dot, and in this case V2 launches, and then execute that query. It'll go off and have a bit of a think about it, and then return all this information. So it's actually converted this information here, which doesn't really mean a lot, into something which is readable in an SQL format, and we can run join queries. We can just, if we wanted to, just select specific tables. So we can do that by typing select. So, and then we can select the tables that we want. So for example, if I wanted to build a table that contained the mission, I just can copy that name there, hit paste, then comma, and then let's say I want to grab one that's the type of rocket. So I can use the rocket ID or rocket name. Well, let's use a rocket name for this one. Copy that one, paste. And let's say I want to also grab the launch site. We can go this, advanced copy and paste. And finally, let's say I want to grab the URL to the video. So here, you could either pick on any of these ones here, but let's pick on the YouTube link. Sorry, not the YouTube link, this one here. Copy that. Paste, and then from auto rest dot v2 launches. And if I execute that query, it'll run off and do its thing, come back with a more concise table, as you would expect if you were doing any other kind of SQL query. Well, this is all well and good, I hear you say, but how did we get to this point? Well, okay, so now here's where I show you. All right, so first things first, in order to understand how the URL is built, we need to go back to the documentation and go to parsing the connection URL in the documentation, and it explains here how to build up the URL. Now, I will confess to you, the first time I read this, it didn't make any sense to me at all. However, after a bit of fiddling around, it's now clear how this works. So basically what we do is we go to our driver. So in this case, let's just close this down and let's pretend we want to change this. So there's two ways of doing it. We could either edit this connection, which is what we're going to do, or you could build a completely new database driver and call it whatever the name of that REST connector might be. But we're not going to do it that way. We're going to actually edit it here. The result is exactly the same. you end up with a connection which connects to the appropriate URL. So you can see here that the name of this, or this JDBC URL, is written up here. Unfortunately, you can't edit it here. What you have to do is go into the edit service, and then in here we change the URL to be what we want it to be. Now, so what I've done is in my Postman, the URL that I'm using for my first example is just exactly as it's posted here. So this is the one that returns the information. I hit copy, I go back into here, and as you can see, it's exactly the same. So I hit paste there. It's not going to change anything, of course, because it's exactly the same. But if we want to change that to something more, another different type of URL or a different type of API, we can do that easily enough. So for this case, we've got an example here, which is using the US Geological Survey data on earthquakes. And we're looking between the 1st of November and the 30th of November last year. So we just copy that URL. And we, again, as I said before, we just replace this line here. So I'll show you in a second what it looks like as a complete line, but just wanted to show you this is how it's done. So here we are, okay, hit okay again, yes, yes, and then what happens is we should get a connection, and there we are. So you'll notice that the table is completely different. We no longer have all those tables, and like I mentioned to you before, if we were to run queries on some of these tables, we don't get a lot of information back. So I'll give you an example. So this table, this query here is no longer relevant. So what we're going to do is go auto rest dot, and then we're going to go VBox. And this will bring back a table which is just information about dates and I think it's possibly to do with some sort of a sample box. Doesn't really tell you much. So what happens is what the ARC has done is if you look here, we have this feature collection, or down here it says type feature. So what it's done is extrapolated that and built a table called features. And if we open up the columns here, we can see that this has got the one that's got all the tables, all the information. So as a general rule, when you're running your queries and you're trying to demonstrate it, you look for the table that has the most information in it, or the most set of fields in it. So if I run this query against this, you'll see here that it has a huge amount of data. Now, what's really interesting about this particular database is that within the data set itself, it's not easy to see, but within the data set itself, there isn't actually a primary key. And when you're wanting to do things like joins or link between different tables and stuff, it's really important that you have some kind of key that enables you to connect the two together. So in this case, what's happened is the Autonomous REST connector has built these three values, or these three fields within the table, which it's derived out of the API, in order for you to be able to use them as joining keys. So it's quite cool. It's quite cool that it's done that. So in terms of being able to then run join queries for different tables, you can use these keys here as your primary keys. Okay, so finally what I'm going to show you now is how to set up the Autonomous REST connector to read a file which has a series of REST API endpoints in it. So if I open up my my file here, this is just a file which we point to, and this will make more sense in a moment. It doesn't really matter what the name of it is, as long as it has the .rest at the end. And as you can see in mine, I'm also using it as a little bit of a copy template to tell me how to build up my different API endpoints. So just so that it's very clear how this works, so you can see here this JDBC dat direct auto rest :sample, which is how it's described here. The same syntax here, and then we, instead of putting equals, it is just, oh, it is an equals, I'm sorry, just an equals, then it's the URL to find the relevant API. That's the whole syntax on how to build up the URL as we showed you earlier. But for the file version, it's a little bit different. It's just instead of using sample, it's using this config, which is telling the REST connector to use a config file, and then we put the path to the file. So in this case, on my machine, it's on my OneDrive file folder, and it's called swappy.rest. All right. Now, what this is going to load is, those of you who've never used there is an API that exists made by some giant nerd who loves Star Wars. And what it is it gives you all of the information from all of the Star Wars movies that have ever been made, including starships, vehicles, species, films, planets, and people. So I've just copied this set of URL endpoints like that, and I've pasted it into my REST file, like, try again, like so, paste, and you can see that's there. Now, what's really quite interesting is you can, with this file, build URL connections that are completely unrelated. So you could have, for example, if I wanted to, I could have one that's, oops, got to have the exclamation marks, sorry, the quotation marks, earthquakes, and then we have like so, and if I grab my earthquakes URL, like so, I'm not sure why that's not turned out the way it should. Oh, no comma there, that's why. Need a comma at the end of that line there. Yep, so there we are. Now what will happen is it will return all these tables here as well as this table here. So there may be a scenario where you're wanting to grab a whole bunch of different data sources from all over the place, and you want to have them brought back in as different endpoints within your REST API connector, or the autonomous REST connector, and you can definitely do that. Now, the next question is whether that's really all that meaningful, because unless you have some kind of primary key, you couldn't really use this information together. So you can't actually build connections between them. But nonetheless, to save on building lots of connections, so rather than having multiple REST API connections using the sample approach, you could use this approach to just build up all your different connections. Now, there is one fairly significant drawback with this approach, and which I'll show you now. Sorry, not trying to calculate anything. That's just a slip of the finger. We go back here. We click close that. We get rid of that. Now what we're going to do is we're going to disconnect from here to show you when we connect to the REST API version. So edit our connection. No, I shouldn't have closed that. I should have grabbed that. All right, here is, we're going to copy this line of code here. Copy. And we're going to edit this and replace this line here with the new REST API connection. Hit OK. Now if we connect to it, what should happen is the ARC will run out and build from all of those different API legs a series of tables. And you'll see why this becomes a little bit of an interesting challenge, because now when we open these tables, we've got a heap of different tables. And what's happened is the ARC for each of those endpoints has built a series of relevant tables. So because there's 1, 2, 3, 4, 5, 6, right? We have films 0, films 1, film 2, film 3, film 4, film 5. So that's 6 different tables. And the same happens to people, the same happens to results, species, starships, etc. Now, you then got to figure out which one of these tables is the one which is going to be relevant. So using the same example as I was showing you earlier, when you start looking at these, if I return films, for example, it tells you next to nothing because that endpoint has not very much data in it. So all this is telling you is nothing. It's telling you 7 rows returned. So that's obviously not the table that you want. So then you've got to figure out which one do I want. So in this case, I happen to know, because if I open this up and I look at the columns, there's lots of information here, that it's actually results. So this is probably one of the things that's probably a little bit of a limitation I would suggest for the ARC, and that is that it's not necessarily very obvious where those results are being returned. So if I click on here, I will see that this is going to correspond. So these are all characters. All right. So if I look here, my first one, which was people. People are obviously the characters. So I know that result with no underscore or result blank is people. If I look for, if I go to result underscore 1 and do that again. And this one looks to me like planets. So I look here, and indeed it is planets. So it's perhaps a little bit unintuitive. Nevertheless, you are able to see that it's built all those results here. So there you go. That's all there is. I hope you found that to be very useful. The AOC is a very powerful tool, and I think that you should have a lot of fun demonstrating it. Until next time, thanks for watching.